So is it visible to you all?
Yes, sir.
Yes, sir.
Okay, fine. So before starting, I just want to say, whenever you feel any confusion, you can ask. Just unmute your mic and ask at the same moment. Okay. If you file anything. Okay. On the other hand, you can put messages in the chat box, but I can check those messages after completion of the lecture. So if you find any problem anytime, you just put on your mic and say ask your question. So as I told, I'm Dr. Kulddep Goswami from Divya University. Today I'm going to discuss about data visualization. So before going to data visualization, we have to have the concept of data, what it is, and which things are called data. And can you give me some example? Can you give me some example on data?
Sir, it can be secondary data, unit level data, so categorical data,
Yes, yes, I can understand, but I am asking the data. What is data? My name, your name,
collection of information.
right? My name, your name, the names are also data or not?
Collection of information.
Yes. So
Information,
there
right?
are some difference between information and data. Okay, just like my name is information, but if you ask each and every participant their name, and if I collect the numbers of the participant, then it will be a data. So there are 14 members present at this time in this meeting, then these 14 numbers will be a data, but the name is the information. Sometimes uh, information, sometimes data implies information, but information cannot be a data. Okay, so let's start. Data may be information. It helps in decision making. It helps to find solution, and to find the solution, we have to understand the data, difference between the data, relationship between the data, among the data, and depending upon the data, we have to go for further analysis. So in statistics also, it starts from collection of data, then coding and editing, then analysis, and then writing of uh, conclusion or the interpretation of the data. So in each stage, we have to tackle it some kind of data. And after coding or tabulation, the raw data can be visualized, or raw data can be uh, put in a graph or in a pictorial diagram, so that a layman can understand what the data says. Okay, generally why we use visualization? We use visualization for a layman, for the common people, so that they can have, maybe those person may not have the idea of statistics or any kind of data, but by seeing the visual representation, they can have some idea about the data set, some idea about the problem. Okay, that's the very basic point of visualization of a data. So in statistics, to quantify uncertainty in social science research, investigators have to deal with different types of data. I'll discuss later on about these things. To use statistical software like SPSS are by social scientists, or say other science background, or say commerce background students or researcher, knowledge of the data and measurement scales are needed. So say SPSS, Stata are some kind of data analytical software, and are nowadays the burning software like Python. Those things, or those software or programming language, knows only the data, means the numerical value. Okay, because statistics always deals with application and analysis of different technique on numerical value. Sometimes we may get some theoretical or categorical value also, just like the what are you reading now? So if I ask a question to the respondent, what is your educational qualification? Some may say I'm fifth pass, some may say under HSLC, some may say HS pass, degree pass. So we have to code those response. Like we can put one for under HSLC, two for HSLC, three for HS pass, four for graduate, five for graduated above, like that. Then only we can use any kind of statistical software, any kind of visualization technique on those numerical value. Otherwise, we cannot have an idea what the data says. Okay, this kind of software knows only the numerical value. So if you have any kind of numerical value, you can just put to the SPSS or R to get some kind of solution. But what type of statistical techniques will be applicable on those data? This kind of things you can get by reading the basic concept of the statistics. Otherwise, you can apply any kind of testing procedure on data, but without having the knowledge whether those techniques will be applicable or not. So as I mentioned, we will deal with numerical representation. Data are the basic input to any decision-making process. Any records, descriptive accounts, or symbolic representation of attribute are constitute a data point. Data are usually measured on numerical scale or classified into categories, as I have already mentioned. But whenever we get some categories or qualitative data, we have to convert to a numerical one through the coding. Appropriate use of statistical procedure requires that we understand the data and the process that generated them. So depending upon the source of collection, we can divide the data into two categories. One is called primary and the second one is called secondary. So primary data are those where the researcher directly go to the respondent and through questionnaire or schedule, they ask some questions about their objective of the research. And this is called primary. Why? Because the respondent directly give their information to the investigator or the researcher. On the other hand, there are another type of data which is known as secondary. And this data actually already collected by some respondent for their respective purposes. Okay. So collected, I have put that collected for some other purposes, like secondary data. Once they are primary, but you are using their data, you in case of secondary data, you collect from sources like internet, maybe register, maybe any other kind of data equation process, but you do not go for the, in this case you have not, or you do not have to go for the direct collection from the respondent. So secondary data are those which already have collected by someone for other purposes. So these are the methods of primary data collection. Observation method. Sometimes it is look like you are going to do a research and you have to collect data from road. The car passes through say you are standing in front of a gate of a college, so you have to collect data how many car passes through a 1 hour interval, or say in 1 hour. So these are observation method. You have to observe how many car have passes through the gate during that 1 hour. Direct personal investigation. Already I have mentioned. In this type, you have to go to the respondent to get uh, the answer of your question. Indirect oral interview. These are some other method through which the primary data can be collected, like indirect oral investigation, investigation through local agencies. You can go to the local agencies to have some idea. Sometimes it is happen like you do not have idea about the people residing in a local place, but you know some agencies working there. Okay, then directly, instead of going directly to the respondent, you prefer to go to the agencies to take some data related to those residents or persons belonging to that local area. And telephone interview, one other method is like through mobile phone. You can, now it is available in each persons in our country generally have uh, minimum one mobile phone. So without going to the respondent or in face-to-face interview, you may prefer telephonic interview. Maybe in case where transportation costing is higher, time of traveling is higher. So instead of going to the person, you can have those data through telephone interview. And mail questionnaire method is also there. In this method, you first have to um, construct a questionnaire, means a collection of some questions, and then you can put those questions to through email to the respondent. Or in the earlier days, sometimes it is happened like the researcher puts some questions in a white page and then mail it or post to the respondent. And after a period of time, they get their response through post also. And schedule sent through enumerators. Sometimes it is happen that you are taking a large sample survey, but you do not have time to go each and every respondent. Then sometimes it is happen like people take help some other agencies to gets those data from the respondent, because in that case the researcher directly do not go to the respondent. Instead of him and her, they appointed some other persons, so that a big amount of data, large amount of data can be collected in a less amount of time. And remote sensing, do you know remote sensing? Is any participant from geography background? As no
Yes,
response.
sir. Yes, sir.
So you may know remote sensing,
Yes,
GIS
sir.
remote sensing, right?
Yes,
Okay,
yes.
these are some collection of primary data. Like by seeing the image, we can have some sample, or we can have some data about the geographical location or about the area, right? These are
Yes, yes, sir. Yes.
examples of primary data. So these are uh, sources of secondary data. I have mentioned some of them. There are two categories here also. One is called internal source and the other one is called external source. In internal source, we have sales record. Just like if you have, if you're doing some research on economics or commerce, then you can prefer to go to a company or prefer to go to a shop, and you can have their data from their sales record. Okay, marketing activity, cost information also there, distributors report and feedback. What maybe some people, maybe you are a company, um, you have a company of some kind of, you have a company some kind of maybe sweet potato or potato chips. Then whether the participants or whether the subscribers or whether the people are taking that chips or not, whether they prefer to purchase those ships, your ships, then the other ships. This kind of data can be acquired from the distributor's report. Then customer feedback also there. You can have that information, or you can see in every product, uh, just like say there is a you are going to purchase a jam, we take generally with the bread, right? So you are going to buy a jam. So in that case, if you see the price, then you can also notice that there are some address of the producer, and there are also email ID, phone number to give some feedback. So this is also a way to get the preference, or whether the taste is good or not, whether customers look good, customer feels it is a good things or not. This kind of things can be have with the customer feedbacks, and these are the secondary data. Why? Because we are not going to collect those data from directly from the respondent. We are collecting those data from the company which taking those data from the respondent. Some external sources are there, like government publication, foreign government publication, and you can see these things in the their respective website, journals, books, magazine, newspaper, annual report, research report, industrial handbooks, etc. So these are some source of secondary data. Okay. So depending upon the type, again, data can be divided into two categories. One is called qualitative, one is called quantitative. Sometimes qualitative data are also categorical, like gender. Nowadays, we can see in the pro forma of any admission process, any job interview, or job written examination, that there are three types of gender you may see in their form, like male, female, and other, right? But those doesn't represent any kind of numerical value, like eye color. Some may say my eye color is white, some may say black, some may say brown. Okay, but these are colors, these are not numerical value. Ethnic origin means like sometimes some people are ST, sometimes ST plains, ST hills. Okay, nationality, I'm Indian. Some may say I'm from Bangladesh. Some may say I'm from Pakistan. Some may say I'm from USA. Those are also data. Maybe they are not in numerical value, but those are also data. But to do any kind of analysis, we have to convert those qualitative or categorical data into quantitative one by putting some numerical value against the qualitative response. Now, quantitative age, you will get some numerical value against this question. If I ask, what is your age? Sorry. So if I ask you, what is your age, you will give some numerical value in your answer. Blood pressure, we know, right? Blood pressure, we each and every person have their blood pressure. One is called systolic blood pressure, one is called diastolic blood pressure. Generally, when you go to the doctor, to a medicine, or say doctor, and they will check your blood pressure and give you two value. One is upper value and one is lower value. So the upper value, which is known as systolic blood pressure, and the lower value, which is known as diastolic blood pressure. And whenever you get these type of values, these are also in numerical manner, right? Now, height, also you will give some numerical answer. Weight, also you will give some numerical answer. So those response of the questions where we get some numerical value is known as quantitative. On the other hand, those response of questions where we get some value which is categorical or not in numeric are known as qualitative data. So based on the observation, again we have two types of data. One is called discrete and the other one is called continuous. So say how many fans are there in your room? You may say one or two, right? This is a number. Maybe someone asks, how many cigarettes do you take in a day? One may say one packet, one may say only two, only three, 5 cigarettes per day. This is some numbers. This is called discrete. Okay. Again, continuous, height, weight are some data which are known as continuous, because you will have height like 171.5 centimeter, 158 centimeter, 5 feet 3 inches. Like in weight, generally we put in if we ask what is your weight, we say 70 kg, 85 kg, 55 kg, but there are also some decimal value there. Okay. So again, depending upon the arrangement, we have three types of data. One is called time series data, one is called cross-sectional data, one is called pool data. I'll give you some example. I'll show you some example how these three categories are different from each other. Okay. First of all, time series data are those which are collected with respect to the time. Say the production of tea for last 10 years. My example is production of tea for last 10 years. In that case, we'll have the total production in 2014, total production in 2013, total production in 15, 16, 17, like that. Okay. Since those data represented numerical value with respect to some time period, that's why those data sets are known as time series data. This is an example of time series. Maximum temperature of Dibrugarh. It is a district of Assam from 1st March to 10th March 2020. Okay. So 1st March 2020, the maximum temperature was 27.7 degrees centigrade. Okay. Up to 10 March, we have 10 data point from 27.7 to 34.3. This is called time series. Why? Because each and every maximum temperature or each and every data point are collected with respect to some time. Here the time is day, right? 1 March, 2 March, 3rd March, 4th March, like that. This is again the maximum temperature of 3 different districts on recorded on 1st March, right? In the earlier example, we have 10 data point with respect to 10 different time point, right? In this case, we have one time point but 3 different data point. Are you getting my point? In this case, we have one time point but 3 different data point. Or we are getting 3 different maximum temperature of 3 different districts of Assam. Okay, this is called what? Cross-sectional data. Now see, again this is an example where we have 10 different time point and 30 different data point, but for 3 districts we have 10 point each. Are you getting my point? I'll show you. Say if I take this as a time point. Is it visible?
Yes, sir.
And if we consider only Dibrugarh, if we consider the time and Dibrugarh, then it is known as time series. If we consider the first row only, if we consider the first row only, then it will be cross-sectional data. Okay? And if we consider the whole data set, one time point, three value. One time point, three value. The whole data set is known as pool data. This is the difference between pool, cross-sectional, and time series. Till here, any question?
No, sir.
Okay, thank you. So again, as I told, there are some scales of measurement. One is called nominal and ordinal. Both are discrete, interval, and ratio scale. Okay, both those are continuous. Ordinal scale like 1, 2, 3. Numerical scale maybe say 1 cigarette, 2 cigarette, 1 cigarette, 2 cigarette, 3 cigarettes. These are numerical. 12 pass, 12 pass, SSLC, SSLC. Sorry. SSLC, HS, SSLC, below SSLC. If I put 1 for this, 2 for this, 3 for this, then it is called order, because 1 is greater than 2, 2 is greater than 3, right? Don't see the numerical value, just see the order. 12 first is higher, HSLC is lower than 12 first, and these are educational qualification. Okay, educational qualification. And HSFL or up to HSLC. Okay, then interval scales are there, like 45 to 55. We have 3 value, 55, 55 to 65, some other value. I don't know why it is not working. Okay, and then ratio scales are also there, like height 166.2, 75.1, 158.4. These are called ratio scale. Okay. So first of all, nominal scale. The nominal scale produces classification of persons or things based on qualitative assessment of the characteristics being considered. There is no concept of greater than or less than. Quality of a product, like good or bad, like gender, male, female, or other. Types of resident, maybe urban area or rural. Some other example of nominal scales are okay. These are the things. Next, ordinal. The ordinal scales classifies persons or things on the basis of characteristics being assessed, as I said. But here we can have greater than or less than sign. Interval scale. 1 unit on the scale represents the same magnitude of the characteristics being measured across the whole range of the scale. Interval scale do not have or true 0 point, like the temperature, right? Temperature 0 means it is not look like there is nothing. Yes, there is something at 0. Why? Because in minus temperature, the water got frozen, right? And these are the ratio. The ratio scale is similar to the interval scale, with the exception then it possesses a true 0 point. Like as I mentioned, the height. 0 height means there exists nothing. 0 weight means there exists nothing. So I will go to the visualization part now. Before this, if you have any query, you can ask. I think you have got a rough idea about the data and its structure, data and its type. It may be different from category to category. It may be different for in case of source, in case of observation, right? So depending upon the data, we have to construct some graphical representation. So for categorical data, the representation will be different. For pool data, time series data, the representation will be different. But during this 2 hour, I cannot give you the whole idea about the data visualization or graphical representation. Just like what kind of or what visualization technique is appropriate for which data set. I'll give you some rough idea, but you have to go through the books or YouTube for better understanding about your data. Because whatever I have, sorry. So whatever I have been teaching you through this class, in this class, till now, these are all about data and its type. Okay, but by after the completion, you will have some rough idea with what type of data, what type of graphical representation can be used on what type of data. But for better understanding, you must have to go through the books. Okay, so it is overlapping. Is it visible?
Yes, sir.
Okay. Charts and graphs. Why important? Easy to understand. As I told you first, a layman who do not know statistics, a layman who do not know any kind of commerce, any economics, any geography, any geology, that person will have some idea or rough idea or some say that person can have some image or can imagine by seeing the graphs, because this is the most important part of a research, so that your research can have some impact on the society as a whole, because each person of the society do not know each and everything of a particular topic, but seeing the graphs, that person can have some idea what is this research for, right? So through the graphs or the charts, it will be helpful or it will be easier for understanding purposes, easy to get the audience attention. Say a person if you are say you are attending a conference and you are a student of economics and you are giving some economic data on the through PowerPoint presentation. In that conference, a person may be from English background attending that conference. That English background person means a person doing research on some English topics or some literature topics in English. That person may not get what you are showing in your presentation because you are showing some data. But instead of this, if you show some graphs or charts, then that person can understand a little bit about your presentation, what you are doing. Can be used to discuss critical point. Sometimes by seeing the raw data with naked eyes, we cannot get any conclusion about the data set. But it's represent what are the critical points, right? But by seeing the graphical representation, we can have some idea, or we can gather some idea. We say this is some instrumental point or critical point which comes from your research. Can be used to summarize also, and can be used to discover trend line. Trend means a long-term movement in a data set. So categorical data, these are some popularly known graphical representation like bar chart, pie chart, and subdivided by bar chart. Have you know about these things? Do you have a heard or do you have seen any kind of bar chart, pie chart,
Yes,
subdivided
sir.
chart? These are some preliminary things. Generally, we get this type of chart or graphical representation in our school days, right? So this is the bar chart. A bar chart compares different categories by using individual bars to represent the tallies for each categories. Okay, so mm, there are 50 students. Sorry, there are 30 students, and our researcher asks those 30 students, which is your favorite color? And the researcher give them five type of colors: red, blue, green, yellow, pink. The researcher told the respondent, that's the 30 children, you have to choose your preferred color from these 5 different colors: red, blue, green, yellow, pink. Then 8 children choose red, 7 choose blue, like that. If I put this in a table, like children and color, red 8, blue what 7, green 5, yellow 9, pink again 6, 35. Sorry, there are 35 children. Okay, by seeing this, okay, this is less amount of data. So it is you by seeing the table, we can say that yellow is the highest and green is the lowest. But some cases when you have a large amount of data, you cannot give that type of conclusion by seeing this kind of tables. No, you cannot get, or you cannot give some conclusion. Why? Because your data set is much bigger than this. In that case, this type of graphical representation will not only help you, but also the viewers to understand. Maybe this is 800. This is 800, and the other one is 800. Say this one 102. Okay. In that case, we'll have some problem. Whenever we are tackling with large amount of data, we cannot get a proper conclusion from this type of table. So instead of giving this type of table, we prefer to go with bar chart. Okay, because by seeing this chart, we can have that idea. The yellow color is a highest amount of chosen by the children. So again, pie chart. So pie chart uses parts of circle to represent the tails of each categories. So here, what we can do, say again, take the last example here. 1, 2, 3, 4, 5 colors are there, and initially there are 35 students, right? 35 students, and some of them choose to have 10, choose to have red color, say forgot the number, 8. So you have to divide 8. The mathematical formula I am showing, 8 divided by 35, then you have to multiply by 360. So some amount of value you will get here, and that amount will be shown here. Okay. In this manner, you can have the other color also. First, why I am dividing 35? Because 35 is the total number of students. Red color preferred by 8. Okay. Why I multiply by 360? Because the whole area under the curve is 360 degrees. So I am converting the raw data to a degree, amount. Okay. So for numerical data, we have histogram, frequency polygon, and cumulative frequency curve. This is histogram. There is a difference between histogram and bar chart, right? In histogram, each point is connected with the previous one. But see, in the bar diagram, there is a difference, right? There is a difference. There is a difference. There is a difference. But in case of histogram, we have continuous data point, right? A histogram is a bar chart for grouped numerical data in which you use vertical bars to represent the frequencies or percentage in each group. When we use histogram like chart, like you have data like below 20, you have, this is age, and this is number of cancer patient. Okay. Below is below 20, you are getting 1. 20 to 30, you are getting 3. 30 to 40, you are getting 7. 40 to 50, you are getting 4. 50 to 60, you are getting 8. 60 and above, you are getting 15 numbers of cancer patient. From where? Say you are doing a research on cancer patient, and this is the value you are getting. Okay. So in your data set, there are one person or children or under the age 20, three patient under 20 to 30, 37 patient under 30 to 40, and this data can be represented with the help of histogram. Okay, but in for bar chart, you will have some numerical value. For red, it is 8. For blue, it is 7. For green, it is 5, like that. Scatter diagram. Whenever you plot some dot in place of straight line or in place of linear line, it is known as scatter plot. So I will directly go to the R programming. So do you know how to, is it visible?
Yes, sir.
Yes, sir.
Okay. So do you know how to import data from Excel?
No.
No?
No.
It is not
No.
not till now.
No.
Okay. So I'll show you one thing before going to the R. So I'm going to draw histogram. Okay, from a data set. I am taking a single value set here. The variable is gender. Okay, and there are some males, some females. Okay, now I have to look how many males and females are available in my data set. I'm not considering the whole data set. I'm for your learning purposes, I'm only considering one variable here. So we have the gender variable, and here the gender is considered only male and female. So this is an Excel sheet, right? All of you may know about Excel.
Yes.
So whenever you save an Excel file for doing research in R, you just go to the file, go to save as, okay, select wherever you want to save your file. Then you have to select a file format. If you seeing this presentation in your laptop or desktop, then you can open a Excel file and you can have these things that you have to save this Excel file in CSV format, comma delimited. It is known as comma delimited. Okay, this I think I have seen the brochure or leaflet of your this workshop, and these things will be taught by someone in later part. But I'm showing just for this presentation only. Always, I prefer to save the Excel file in CSV format, comma delimited. Okay. So as I have already saved these things, I won't do these things once again. Okay. So this is my Excel format saved in CSV, .csv format. Generally, the Excel files are on .xls, but for R, you can have this in CSV. So open script, I already write some code for bar chart. Okay, wait. Is it visible?
Yes.
So you can write my laptop going in hand. Just wait. Is it visible?
Yes.
Okay. Here, I'm assigning this file, the new file, which are saved in F drive through read.ssb command. Since my file is saved as .csv format, so I have to use the command read.csv. Okay, you can write these things in your notebook. Maybe in later class you will have this idea. So after read.csv, you have to start a bracket, then quotation. Under the quotation, you have to write the path of that folder file. This is the path, f dot slash colon slash, and this is the path work Department of Science 2022 workshop new folder slash. Up to this is the path of the file, and here this is the name of the file that I have saved in CSV format. Okay, this is the quotation close, comma. You have to put another thing there is header true. Why I'm giving header true? Because in my data, this one is gender, and this is the header of my data, or the name of the variable, or name of the column. Since I have the name of the column or name of the variable, that's why I am putting here header true. So it is look like you have uh, for import data, for import you will have um, data Okay, this is a name. Then read dot csv. Okay, bracket open, quotation, then path name, path of the file, path of the file, slash file name dot csv, quotation close, bracket quotation close, then comma, header, 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 sorry, this one small h, header, header equal to t. T means true. In place of true, you can simply write t also. Okay, you do not have to write both true and t. Just write t only and bracket close. If you do not have uh, name of the variable or name of the column, then just write f here instead of t. You just have to write f. F means false. So this is my, by reading this, it's not coming. Let me reopen these things. This one. Okay. After this, you can see what you have imported from R. Just put A here and press enter. So you will get the exactly the same data set what you have, what was in the Excel file. First, I assigned this file where to a name A. A is a variable here. I put this file to a variable A. Then I put I press A and then press enter, and I'm getting the same Excel data in my R. This is the way to import data from CSV file. Now I need bar plot. Okay, so for bar plot, I have the command barplot, and I have to write a under bracket. Why a? Because the variable name what I have assigned is a. Okay, now select bar plot and then run. So an error is coming. What is the error? Error in error message is height must be a vector or matrix. So because my value is in count data, so first I have to table this data. Okay, I will show you how it is, how it will be look like. So next, I have to make a table from the raw data point. To make table, I have to use the command table. So by clicking this, it will, okay. This is my original A. I have imported the CSV file. I press A and then press enter. I will get the exactly same data set what was in my Excel. Then after I use the command table A, and I am getting a table like value. Like we have 13 female and 18 male. Okay. Now say I'm giving a name to the table. The name of the table is count. I can do these things in these steps also, but instead of doing this, as you are in preliminary in R, so I am putting count for table A is a name. So run these things. Oh, sorry. Run these things. So count A. Okay. And if I select count only, or if I now I assign table A to the count variable name. So if I use count, the same things will be given here. Female 13, male is 18. Okay. Now to use the what is our target? Our target is to draw bar plot of what? Of those data set. Of that data set. In the data set, we have only the categorical value male and female. So bar plot is the code. BARPLOT, bar plot is the code, and count is the name of the variable what we have given to the table, right? I have named the table as count, so I am putting bar plot command to the count. So this is the bar plot. Okay. You cannot see the difference between table and the graphical representation because this is why, because we have less amount of data. Sometimes it is sometimes there are many more categories in the data, right? Like in the educational qualification, we have two HSLC candidate, HSLC pass candidate, HS pass candidate, graduate candidate, graduate and above candidate. When the categories are much more larger than to understand in a table, then we can have some idea from the graphical representation. Because without seeing the value of the male, we can say there are the male respondent is higher than the female in this research. Okay. Again, we can have percentage of this data also. To convert the table into percentage, we can simply, since there are 31 data points, we divide the table A by 31, right? And write the percent. So actually, one thing is there, we have to multiply these things with a 100. Then only it will go to the percent. This one. Now I use bar plot on percent variable. The percent variable is table A divided by 31 into 100, right? Now if I use the bar plot command to the person, then it will be look like this, right? Female, male, and this one. So naming the bar plot. Again, I am using bar plot count. This is the final coding of the bar plot. These things can be done in the very first stage, or first step when you use the bar plot. Instead of doing this, I am showing step by step. Say bar plot. Show you the graph. One second. This graphical representation is incomplete without the labeling, right? Say this one. Data. Okay, this is the bar chart, but without labeling, a chart or graph is incomplete. I am showing you the bar plot of count. X lab is for x-axis, right? For x-axis, we need a name gender. For y-axis, we need the name number. Okay, mean, gender, frequency. I'll show you what will happen by using these things. This is the difference. You have to write bar plot command, then the name of the variable. Okay, then x lab for x-axis. What I want to write in the x-axis? Gender, right? This gender must be in between two quotation. Next what I need? Number. Why? Because gender, we have male and female, and in y-axis, these are the numbers. I mean, there are 13 female. 13 is the number. That's why I use number in the y-axis. Okay, and at last, main. Main means the main, the title of the graphs, the title of the graphical representation. What? Gender frequency. We are getting the gender frequency of the data set. How much female are there? How many male are there? Okay. Do you find it difficult? Hello.
No, it's okay.
So next one is histogram. Again, whenever you do not have data, you can have some simulation. Simulation means, do not go too further to that. Just I'm taking some random numbers, 100 random numbers. I'm generating 100 random numbers which follows normal distribution. Okay, these are some continuous data. Why I'm using these things? Because to show the histogram for you. Okay, I'm generating 100 numbers. The numbers are look like this. These are the numbers I'm generating to show only the histogram part. Okay, so to plot histogram, we have the command hist, 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 under bracket a. Again, why a? Because a is the variable name, right? see hist and some graph already here. Yes, this is the graph of the histogram. Okay, I already told you that there is no difference between 1 lakh to 2 lakh. In case of bar diagram, there are some difference, but in case of histogram, the difference between 2 lakh is not available. Okay, this is continuous data. So again, we have for naming hist A, ylab is nodes. I'm depicting ylab as node, xlab as frequency. So by running, yes, this one. ylab is nodes, xlab is frequency. In the earlier example, I have put xlab before ylab. So it is not necessary that ylab should be writing fast or xlab will be writing fast. Both cases, both will apply to your histogram or any kind of graphical representation, but you don't have to use these things under a bracket, under one bracket. Okay, because this hist command works from this bracket up to this bracket. So you can put A in later part also. Here also you can put A. Okay, but for lab name or axis name, you put the name inside quotation. Otherwise, you will see some error. Like I'm deleting the colon. Let's see what happened here. Error, unexpected symbol in hist. This one. Why unexpected? Because this symbol is missing. Are you getting my point? So next, multiple bar chart. Again, this is another data set where I am questioning some respondent. Nearly 43 respondents are there. I'm getting their gender and the use of tobacco. The first respondent is a male, and he told me that he used tobacco. Second respondent is also male. He do not use tobacco. Third respondent is male, but he used tobacco. Like that, sixth respondent is female, but she do not takes tobacco. Like for 7 and 8, 9, 10, 11, 12 respondent are female, but they take tobacco. Okay. Now, in this case, we have two different variables. One is gender and one is tobacco. And two different variables or two different responses from one participant. Say, this is number 1 participant. This is number 2 respondent, number 3 respondent, number 4 respondent. Like each respondent have response in two questions. For two questions, one is for gender, one is for use of tobacco. In the earlier cases, we have only one response per respondent. That's the gender. But in here, we have two response per respondent. In this case, what we can do, we can use multiple bar chart. Like the first one is for reading the CSV file. Okay. Next, I table the raw data set. I'll show you the data set here. Sorry. Okay. This is the data set as it was in the Excel. I just converted into a table through a table point. As in the bar chart, I use the table command. Here also I have to use the table command, and through this table command I converted the raw data set into a table like this one. Now see what we have got. The new name is a table 1, a dot table 1. So this is yes, female. No, this is are in sorry, these are in proportion. Okay. Okay. These are first one is okay. I'll show you a. We are using two command here. One is table for to convert the original dataset to table, and prop.table to convert the table to proportion. Okay. I'm showing you the first command. A dot table for the conversion up to onto table. Now I want to check what I get after the conversion. A dot table, write a dot table, and then this enter, and yes, this is the result. It is also known as contingency table. Why? Because we have some row value, we have some column value. Each value gives some results in row wise, in column wise. From this table, I can say there are 10 female who do not take tobacco, but 8 female take tobacco, right? In the same manner, 12 male are not taking any kind of tobacco, but 13 male are taking some kind of tobacco. Okay. Now, in this case, when we have response from two different sides, vertically and horizontally, in this case, we have to use what? Bar plot, multiple bar plot. But in this case, we can again use bar plot, but where? A dot table, and I'll show you how it looks like. After getting the table, I will describe which represent what. Okay, see these things. Black are female, white or off-white are male, or as colors are male. Okay, yes means consumption of tobacco. So from this diagram, I can say from my data set, male respondent take tobacco higher than the female respondent. Also in case of no, female are higher. Okay, if I took the proportion, it will be look like if I say take the true proportion, in that case, female is the female figure is higher in case of those respondents who do not take tobacco. Okay, but when we see this one, sorry, where? Yes, this one. But from this diagram, when we put the raw data, then we see male respondent is higher. That is why because we have 10 respondent and 18 female and 25 male. But out of 18 female, highest number falls in the group who do not take tobacco. Out of 18, highest numbers of female are not taking any kind of tobacco. But in this case, we have 25 female, but though the persons taking tobacco is higher, but the difference is very less, only one. That is the reason why we get a different results for proportion. Now come to the coding. Also the first coding. This is bar plot. Okay. A dot table means after converting the raw data, beside T means true. Okay. As I put beside equal to T, so this two figure, see the figure, the both leg are coming one after another. Since I have put beside is equal to T. Let's check what if we put F here. Since I put beside is equal to false, so one is coming above the another. Right? So instead of doing this, by seeing this, you can also give some comparison or give some comment, but I generally prefer to use beside equal to T so that suitable conclusion can be drawn. Okay, then legend, Legend. Legend means this one, row names, a table. Legends means the things what I have given in the graph and what the color depicts for. Legend means I have to, like in Excel, you can see these things also. Which color stands for what? Now I am giving row names. Since I am getting this value for gender, so why? And see my table, my row name is female and male. Okay, that's the reason I am giving here row names of the table. If you put here call names is COL for the column names. What it look like? No, yes. So for this graph or for this problem, it will be wrong. Why? We have yes, no in the x-axis, right? And if the no colors depict for black and y is yes, off-white stands for yes, then you will get a wrong conclusion. Because here yes and here no. This one yes for the axis, depending upon according to the axis, x-axis this is yes. Again here you are getting no. So this is row names, ROW, row names, and then a dot table. Row names of what? Of the table. Okay. So this one also you can say yes. Bar plot of what? A dot table. Bar plot of a dot table. Besides, yes. So I am putting true. Listen, what? Row names, a dot table. Y-axis count, since it is the count data. Then, sorry, count data. Then Y-lab count, and there is no X-lab. What should I write here? X-lab. Can anyone say? Am I audible to you all?
Yes.
Yes, sir.
What should I write here? This is the count value. How many no's are there? How many yes are there? And for no and yes, what should I write? Like, since these are numerical value, I use count. Can you say? So I can use here use of tobacco. So by writing this, yes, this one, because right, gender and tobacco, right? That's why, sorry, that's why you have to give proper name for proper axis, so that you will have some understandable graph or graphical representation. So by seeing this graph, one can say male, yes, male conserve higher amount of tobacco than the female. But this result is true for only your data set. Okay. But yes, you can have some idea about your data set by seeing the results through graphical representation. Go ahead. Yeah, I'll show you another. Line trend. I'll show you another data set. Yes, this is a time series data set. Why? One time variable is there, one response variable is there. Here, the number of tourists arrival of some places are given from 1999 to 2018. Okay. But the problem is you have to check what is the characteristics of this value, how it is looks like, how it is going on. Where if any person can ask you or say like by seeing this data, what you can do, what kind of statistical analysis you can do some statistical analysis. Sometimes some may say do some statistical analysis on this data set. So before going to apply any kind of statistical techniques, you have to have some rough idea about your data set, and that kind of rough idea is generally given by the graphical representation of the raw data set. So from this data, you can ask a question, or you can have a question in your mind that how it look like, how the change is occurring. Is there any change from 1999 to 2018 in the tourist, or there is no change occurred till now from 1999? So this can be done through a straight line or scatter diagram. Okay, I'll show you the line. So this is my data. I'm taking from the CSV file. So it's look like, yes, the same data is coming for me from the Excel, as I have saved the data set in Excel in CSV format. So by using plot command, P-L-O-T, plot A, by using plot command, I will have a graph. This is scattered diagram. Why? Because we are getting some point value. Okay. This is the year and this is a tourist. Right. See, in this case, whenever you plot the data, there is no need to give header is equal to true or false, right? What is the value name of the Y lab? What is the name of the X lab? Those things are not necessary generally in case of the plot command. Okay, but plot command generally gives you a line type diagram. Say plot A is my original data set, plot A type 1. Now see how the change will occur. Now it will convert to a line graph. Okay, instead of this, I can use two. Oh, sorry. Okay. No, it is not working. L. Okay. Are you getting my point? If you need now from this, we can say by seeing the raw data set. Right, this one. By seeing the data set, if you see the data set, there are 20 different time points from 1999 to 2018, and you can say yes, the arrival of the tourist is gradually increasing. Why you can give this comment? Because this is only 20-point data set. You are seeing the first value is 9,64,000 something, and the last value is 5,93,000. Okay, this is a small amount of data set. That's why you can say yes, the arrival of the tourist is gradually increasing. But what happened when you have more than 3,000 data? At that point of time, you cannot have that idea from by seeing the raw data set. That's why we need the graphical representation or the visualization of a data. So by seeing this line graph, we can say from 99 or near about from 2000. Yes, this data is from 1999, but you can say from 2000, near about 2000, the arrival of the tourists is gradually increasing. Why? Because this curve is going from here to here, an increasing manner. A long time movement in a data set, in a time series data set, is known as trend. Okay, this is another part. I'm just telling you these things because this is related to this graph. The long time movement of a time series data set is known as trend. Since it is started in the year 1999 and up to 2018, we are getting a upward curve. So we can say the trend is in increasing manner, or say in the the data set exhibits a upward trend. Okay. Now I'll show you another visualization technique. pi. So I have given you the definition of pie chart with a mathematical example. Now came to the first, yes, first example, gender. Here we have one response per respondent, right? I'm asking the respondent that what is your gender, and depending upon his gender, he or she may reply that I'm male or I'm female, okay? Or I may be in other, because I'm not taking that other into account in this practical example. I'm taking only the male and female. So yes, I have idea that this is the percentage of male, this is the percentage of female. But you can, if you have a big data set, a large amount of data set, and if anyone asks you a question like, what is the proportion of male and female to your data set? Which one is bigger? Whether you have a larger amount of male data in your data set, or larger amount of female in your data set. Those kind of things can easily be interpreted with the help of pie diagram. So this is the data set. Why? The same error was there in histogram, right? So for to delete or to overcome this error, we have to convert the original dataset to a table. So I use table command. So yes, since this is a we have lesser amount of data, so we can say yes, male respondents are higher than the female. Now count. Same thing as like in the histogram. Just yes. This is the pie diagram. For pie diagram, I'm using the command pie, P-I-E, pie. Okay. I'm using pie command on the count data. Then I'm using a main command, main. Why? To get this gender and frequency. I don't have to write which one is male, which one is female, because it by default coming with the pie command. So from this figure, we can say the proportion of male is higher than the proportion of female. Okay. So to add labels, we can use, yes, to add labels, we can use labels equal to paste within bracket names of the count. Say here only the count value 13 and 18, initially 13 and 18 was coming, sorry, male and female was coming, but now I need the names and count, and this separated by this one actually the dash between female and 13 is this one, and the main is gender. So for female is equal to 13, or we can paste sorry, this one. Okay, this is the results. So this is the labels equal to paste. Paste is the command. Okay, why I'm saying paste is the command? Because after paste, one bracket is open and another bracket is closed. Under these two brackets, we have to write names. Names of what? Names of count. Then a equal sign. Then the count. Count means the value. Names equal to count. names of the gender. In case of our problem, name of the count is the gender, equal count, comma count. Count means the value. Okay. Then another point is there. So this is not working here. Okay. 5. So count, label, paste. Paste is the command here. What? Names, count, comma, PCT. PCT means the percent of the data and percent sign. Okay. So whatever you need for your graphical representation, you just have to use the labels and paste. Okay. So in our case, 58% are female and 42% are male. Apart from this, I will show you yes, some other example. So this is a air quality index, or say air quality data set. Ozone, solar, wind, temperature, month, day. So in the month of May, 5 means May, I'm collecting data from day 1 to day 6 and getting some temperature. This is not like general air temperature, wind, solar, and solar radiation, and ozone store. Forget about the characteristics of the data. Okay, just remember this is a time series data. Why? Because we are collecting this data against to some time point. So this is the ozone concentration in the air. We are getting from this first column, the first picture, ozone concentration in the air. Okay. This is the I'm showing only the codes. If you need, I can share these things. Bar plot, air quality of the zone. Air quality of the zone means the OCA zone. This is the name sorry. O zone is the name of the variable. Main means this thing. Ozone concentration in air. X lab means this one, and horizon is true. If I put horizon is false, then graph will be appeared like this one, horizontally. This one now horizontally. Horizons is coming for horizontally, stands for horizontally, and because since I am putting true for horizon, that's why it is coming look like this. If I put horizons is equal to false or F, it will be look like this, means vertically. So it is on the vertical, as I mentioned, false. So this is a daily maximum temperature of some airport. Okay, this is histogram. Data is air quality. So I already mentioned these things already. So here this COL represents the code for color. Okay, this is command for the color, and frequency is true. That's why this data set is coming in a frequency manner. Okay, this is the box plot. So average wind speed of that airport, and we are by using the command box plot. Using the command box plot, we are getting this type of graphical representation. Yes, this is also a box plot diagram. This is the scattered plot. Again, you have the data set as air quality, you just have to use the command plot here, and the other things like xlab, ylab, pitches, pch. Here you are getting a pch. This is for how much you need these things. If pch is 20, it will be darkened. If pch is 15, it will be softened. How much dark you need? So thank you for now. If you have any question regarding these two presentations and as well as the our representation, you can ask. Otherwise, I will stop here.
Hello.
Yes.
Thank you, sir, for your nice presentation. Sir, I have